Question number 1. The question given is, which of the following interpolation technique is used to find the value of function at point lying outside the known data points? Options given are Newton forward interpolation, Newton backward interpolation, Newton divided difference interpolation, and Lagrange interpolation. Let's consider option A and option B here. Option A, Newton forward interpolation, and option B, Newton backward interpolation. Both the methods are used to find the approximate value of a function at a point within the range of known data points. It involves constructing a difference table and using finite differences. So basically, they are not designed for the point outside the known data range. Therefore, this cannot be the answer. Coming to the option C and option D. Option C and option D, Newton divided difference interpolation and Lagrange interpolation. These techniques used to find the value of a function at a point lying outside the known data point. This involves the constructing polynomial using divided difference, and this involves constructing polynomial using Lagrange basic polynomial. Both C and D would be the answer, but the most appropriate one would be the Newton divided difference interpolation technique. This technique is specifically used to find the value of a function at a point lying outside the known data points. It is achieved by constructing a polynomial using divided difference that makes it suitable for interpolation beyond the data range. So for me, answer would be option number C, Newton divided difference interpolation. Coming to the question 2. In question 2, it is asked, which of the following is not a disadvantage of Newton forward interpolation? Option A, it cannot be used for large values of n. So this is the disadvantage. As the number of data point increases, the complexity of forward difference table also increases. Therefore, the computational requirement also increases. Therefore, it becomes more challenging to handle the large values of n. So this is the disadvantage. Coming to the option B, it requires equally spaced data points. The Newton forward interpolation method relies on the equally spaced data points. This is because to calculate the forward difference table accurately. So if the data points are not equally spaced, the interpolation result may be less accurate. So this is the disadvantage. Coming to the point C, it is sensitive to error. It is sensitive to errors in the data point. The accuracy of interpolation heavily depends on the data point the accuracy of data points. So if there is an inaccuracy in the data points, it will affect the interpolation value. So this is also a disadvantage. Coming to the option D, the computational intensive. It is not a disadvantage, because as we compare the forward interpolation method with the other interpolation methods like Lagrange interpolation, it is generally considered forward interpolation computationally effective because it involves the constructing difference table, which is forward difference table, which can be done in a straightforward manner. So the correct option would be option D. Coming to the third question, here given is, which of the following interpolation technique is used to find the value of function at a point lying before the known data points? Options are Newton forward interpolation, Newton backward interpolation, Newton divided difference interpolation, and Lagrange interpolation. So here comes Newton forward interpolation. Newton forward interpolation is not the answer because it estimates the value of a function at a point lying after the known data points. Option B is Newton for backward interpolation. The Newton backward interpolation is the answer. Uh, sorry. Newton backward interpolation is the answer because Newton backward interpolation is specially designed to estimate the value of a function at points lying before the known data points. So it involves constructing a backward difference table using the finite differences to interpolate the function value at a desired point. So the answer would be the backward interpolation, as it estimates the value of function at a point lying before the known data points. As we have seen in the question number 1, Newton divided difference is estimate the value outside the data points range, and same as with the Lagrange value. The correct answer would be option number B, the Newton backward interpolation. The fourth question is, which of the following interpolation technique uses a polynomial of degree n minus 1 to interpolate n data points? The options are Newton forward interpolation, Newton backward interpolation, Newton divided difference interpolation, and Lagrange interpolation. In Newton forward interpolation, backward interpolation, and Newton divided difference interpolation, the degree of polynomial can vary depending upon the order of interpolation at a given data point. So the polynomial degree can also range from 0 to n minus 1 in 3 of the interpolation techniques, depending upon the data points, where n is the data point. Similarly, these are so these cannot be the option. So the option is D, the Lagrange interpolation. In Lagrange interpolation, the polynomial degree is fixed to n minus 1, where n is the number of data points. So the correct answer is option D. Question number 5. Which of the following is not a disadvantage of Newton backward interpolation? A, it requires equally spaced data points. So this is the disadvantage because the Newton backward interpolation relies on the equally spaced data points. This is because to calculate the backward difference table accurately, so the data points are not equally spaced in interpolation. As a result, it may be less accurate. Coming to the option B, it is sensitive to errors in the data point. The accuracy of interpolation heavily depends on the data points. If there is inaccuracy in the data points, it will affect the interpolation value. So this is also a disadvantage. It cannot handle a large values of n. So this is the advantage. This is not the disadvantage of Newton backward interpolation, as it can handle the large value of n data points, as it can handle the complexity because of the backward difference table. So it can handle more more large values of n. So this is not the disadvantages of the backward interpolation. It is computationally intensive. Of course, the backward difference table is used, therefore it is computationally intensive. It is quite difficult to create the backward difference table. So therefore this is also a disadvantage of backward interpolation method. Question number 6. Which of the following interpolation technique is used to find the function at a point lying between the known data points? Options are A, Newton forward interpolation, B, Newton backward interpolation, C, Newton divided difference interpolation, and D, Lagrange interpolation. As we have seen before, the Newton forward and Newton backward interpolation are primarily used to approximate the value of function within the known range of data points. or the Newton forward is used for the after points, and we can say Newton backward is used for the before points. But these are not the correct option because they do not find the value of function of at the point lying between the known data points. Let's see the option C and D. In option C and D, the Newton divided difference interpolation is the method that can handle both interpolation and extrapolation. It involves constructing a polynomial using divided difference, as we have seen before, which is used to estimate the function value at a desired point within or outside the known data range. So this can be used, but this is not the most commonly used. The most commonly used is Lagrange interpolation in this specific condition. The Lagrange interpolation is widely used technique for finding the value of function at a point lying between the known data points. It constructs a polynomial that passes through each of the given data points, allowing the interpolation between those data points. So the Lagrange polynomial can accurately estimate the function value at a desired points within the data range. So this is the correct answer because it can accurately measure the values of function function at point lying between the known data points or within the data range. So correct option would be option D, Lagrange interpolation. Moving on to the question number 7, which of the following is the correct formula for Newton divided difference interpolation? This one is the formula for the Newton divided interpolation. So this matches the option A. So therefore the option A is the answer for this. As this you can see here uses the divided difference formula for the Newton divided difference formula. So option A is correct. Second, the next question 8. Which of the following is the correct formula for the first dividend difference in the Newton divided difference interpolation? For the first dividend difference, the formula for Newton divided difference is given here. You can see it over here. This is the formula for the first divided difference for the Newton divided difference interpolation. So this formula matches the option D. So option D is the correct. Here is given how we can calculate the first difference divided difference from the formula of the Newton divided difference interpolation. So this is given here. You can see it over. This is the formula for the Newton divided difference here, and this is derived the first divided difference. The next question come here is question number 15. What is the order of polynomial used in the Newton forward interpolation? This we have seen already before. The order is n minus 1. This is start from the range 0 to n minus 1. They start with the range 0 to n minus 1, and the higher ordered polynomial is used as n minus 1. So the correct option is D. Coming to the next question. Which of the following interpolation method is used the concept of interpolation error? There the Newton forward and Newton backward difference interpolation do not involve the error correction. Here Lagrange interpolation involves the error correction, as Lagrange allows a calculation for an error boundation or estimate for the interpolation error. By considering a derivative function being interpolated, the Lagrange provide a way of estimating the maximum error between the interpolated value and the actual function value at a specific points. Here's the formula for the error bound in the Lagrange theorem. So Lagrange method of interpolation uses the concept of interpolation errors. Coming to the next question, which of the following interpolation method can be used to interpolate the function of a complex value? So here uh, we have seen before that the Newton forward and backward are not estimated for the complex value, so these are not the correct options. Coming to the divided difference and the Lagrange interpolation, the Lagrange interpolation can indeed be used by the interpolated function for the complex value, as it do not restrict any natural or the imaginary function, real or complex. They do not restrict the value. In this above three methods they restrict this, but in the Lagrange interpolation there is and they do not have any restriction of the natural functions or the real or the complex functions. So the correct option would be D, that D is the interpolation method which can be used to interpolate the function with the complex value, as it allows the real and complex functions also. The next question, question number 18. What is the drawback of using higher order differences in Newton divided difference interpolation? Higher order computational complexity, decreased accuracy, higher degree of polynomial approximation, none of the above. So the seeing the option A, higher computational complexity, obviously this is the drawback of the Newton divided difference interpolation technique, because in this technique we construct a divided difference table. To construct that table, the higher order differences can create a complexity in the computation. So this can be a true option. Decreases accuracy, this is not the true option, because as the higher order differences comes, the accuracy increases. The higher degree of polynomial approximation, this is also not the correct option, because the polynomial approximation do not depend on the higher order differences. Therefore the correct option would be the higher computational complexity, as we create the divided difference table for the Newton divided difference interpolation. Coming to the next question, what is the main difference between the Newton-Cotes formula and Gaussian quadrature formula for the numerical integration? The options are A, the Newton-Cotes formula are used equidistant points, whereas Gaussian quadrature formula uses non-equidistant point. B, Newton-Cotes formula uses non-equidistant point, whereas Gaussian quadrature formula uses equidistant point. The option would be the A. The A is correct option. As we see, the Newton-Cotes formula contain two methods. First is Simpson methods, and second is trapezoidal method. The both method contain the points. Uh, uh, Find the equidistant point from the integral function. So this is the correct option. So in the question number 19, the A option is correct. Which of the following is an example of Newton-Cotes formula for the numerical integration? As we have seen above, the Simpson and the trapezoidal rule both comes under the Newton-Cotes formula for the numerical integration. So the option would be the C. Both A and C comes in the example of Newton-Cotes formula for numerical integration.